Okay, folks, this is to rectify the error that has been made while making the example number 2. You know what the error is? It is right here, okay? The point load acting on B4 is not correct. So if we go back to see the floor plan again, you see that this is our B4, okay? Here's our B4. You see that this is the column that it is support, and at this point B4 will be supported by B5. So you can see that B4 in turn will support 3 B1s here, but this beam that B4 is supported is not actually B1. That is not right. So here is not B1, it's more like half B1, okay? So we need to do some analysis for this beam on the edge to get the proper loading that will act on our B4. So we can do so by repeating the calculation of B1, but right here we can reduce the tributary width to just half of it, which is 0.8. So let me recalculate that, okay? So point load on overhanging portion of B4. It's gonna come from that beam on the edge. Oops. Okay, that's it a lot. All right, so that's the beam with the uniform load, which this time is gonna be just 0.8 of tributary width, then date load and live load 500 and 400. Am I correct? Let me scroll back up and see. Okay, and then plus the self weight of 300. So that means we got 0.8 multiplied by 900 and then plus 300. Okay, so the load is 1020 kilogram per meter. So that means the reaction is going to be that multiplied by half the length, which I don't recall, so I have to scroll back up. So it's 4 meters or 8/2. Okay, that's 4 meters. So that's 4080 kilogram force. So the correct loading here will have to be 4080. But this is very fortunate because I use superposition to calculate the reactions of B4. So that means this is already correct. That is already correct. And all I have to do is fix this one. Okay? So that reaction will just become hang on, I don't want to write it over here, it just might confuse you, so I'll leave it on top like that, and I will calculate just this portion of my superposition. Okay, so here instead of having the old load, we're going to change that into 4080, meaning that this reaction is just 4080 multiplied by 5/4, and that one has to be downward. 4080 multiplied by 1/4. Okay, and this is equal to 5100 kilogram force, and this guy is hang on, is 1020 kilogram force. So okay, now we're gonna have R1 equals 10,440 plus 5100 plus 1500. So that is okay, 17,040. and R2 will become just the same, but oops, that has to be minus, right? Yeah. Okay, one moment. That's 10,000 and 320. Okay, so we're just gonna have to reanalyze our beam, you know, no big deal. And that's a good old shear force diagram. Now, what do we have here? Okay, so our shear force diagram is gonna look like this. Begins with minus 4080, and then it comes down with the uniform load, which is 300, and our cantilever is 1.6, right? Let me check. Yeah, okay, just like here, but it begins with minus 4080 and then minus 300 multiplied by 1.6, which is the cantilever length. So that gives us here V1. V1 is minus 4080 minus 300 multiplied by 1.6, okay, which is minus 4560. And then you meet with reaction number 1, so goes back up to V2. Okay, V2 is therefore minus 4560 plus 17040 is equal to 1200 and 1480. Okay, so we are going back down again to V3, which is that one, minus 300 multiplied by another 1.6. We all have all of 1.6. Yeah, I think so. Okay, and that is minus 300 multiplied by 1.6. So it's exactly 12,000. Okay, that's your V2 and then V3, and then you meet another point load. So that's that point load is correct, which is 6960. That's the one. So V4, it's 12,000 minus 6960. Okay, so it's 5040. And then you continue on, which means V5, see, this is minus, yep, and then the V5, this is V4, right? V5, you continue on, so that means it is 5040 minus another 300 multiplied by 1.6. So it's 4560. That's V5. And then we meet another point load, which is 6960. So minus that. Now we have V6, which is equal to minus now 2400, and then again V7, we minus that with the same term, which is the uniform load, 300 multiplied by 1.6. So that's the minus 2880, and then I believe that's another point load, right? So minus 6960, and then you have, too lazy to do this, so this is minus 9840, and then with that we should come down to, yep. So that is the correct shear force diagram. And for bending moment diagram, you know, it's just more the same. Maybe I should change the color. Okay, maybe blue will do. Okay, and we know this area is negative, so it should give you this value. Okay, the V1 is the 4560 plus 4080 divided by 2 multiplied by 1.6. So that is minus 6912. Okay, and here I bet you can complete that. This negative area here should bring your moment down to 0. So in turn, it should give you the positive value here. Okay. All right. So this value comes from the area of your shear force diagram, which is V6 plus V7, so that's 2400 plus 2880 over 2. They are multiplied by 1.6, right? They are the same, so I am just going to factor 1.6 out, so that's 9840 10320 over 2. This is multiplied by 1.6. Okay, so let me do a little calculation. So that's 20,000 and 352 kilogram meter. So that's the correct one. And notice that the reaction here R2 also changes, so we have to recalculate B5 as well. And that's the wrong one. Maybe I should do something about that. Okay, like that's wrong. Okay, and now here's B5. So what will change is this reaction is going to change from 9600 to what's that, 10,320, right? Yep. So this has to change to this number, and then the procedure is the same. Okay, this one is going to be simple because it's symmetric. Okay, so the reaction here, you just change this into that. So so the difference is 720. Okay, these two numbers, the difference between these two numbers is 720. So that means I can add 720 to the existing reaction. So our new reaction is going to be 15912. Oh, how confusing! You know, the old one is 15192, so the new one is 15912. Okay, so it's no, not much change. But anyway, because it's my mistake, so let me try to rectify that. Okay, we changed a little bit. So our shear force diagram now should look like this. Okay, instead of beginning with that 9600, we now begin with 10,320. Okay, it's just gonna come down with the uniform load. V1, oh, the load is, yeah, that's the load, right? So V1 is minus 10,320, and then minus 1020 multiplied by 1.2. So that should give us minus 11,544. So that's our shear force V1. And then this will go up with the amount of the reaction itself, which is now 15912. So that means this is 4368. And due to symmetry, this should come down to 0, all right? And our bending moment diagram, beautifully, not very straight. Let's do it again. You know that this negative area will give you the negative moment, right? Piece of cake, right? So right here, this value at this point is going to be that area, which is 10,320 plus 11544 over 2 multiplied by 1.2, right? Is that correct? Yeah. Okay, so hang on. It's 13118. Okay, and then again we have this positive area, which may not be enough to bring this moment diagram back to positive value, and this area itself is equal to a half of 4368 multiplied by 2.8, if not mistaken, because I just saw, yeah, it's 5.6 span length, internal span, so that's 2.8. So 4368 multiplied by half of 2.8, so that's 1.4. So that is just 6115. Okay, so that's not enough. To bring that back to a positive value. So you have negative moment here, say about 7,003 actually. Okay, so that's the correct value for everything. All right, hope that everything is okay for everyone. So sorry for the inconvenience.